In this video, you'll have an understanding of what imperative languages are, to be able to describe machine language and assembly language, and understand the advantages and disadvantages of machine code and assembly language. So let's have a little look at our language hierarchy. So at the moment we're just focusing on high-level languages, and we went through the difference between high-level and low-level languages in the last video. Now, there are hundreds of high-level languages, and very broadly speaking, at an abstract level, we can categorise them as imperative high-level languages and declarative high-level languages. Imperative high-level languages is program code where we execute one line at a time after the other. The code is written by the programmer using constructs like sequence, selection, iteration, and the programs are built up in blocks of code, often referred to as subroutines, procedures and functions. It's not strictly true, but often people use the word procedural language to mean imperative language, and this can be anything like C#, Java, Pascal, Python. It is more than likely a procedural or imperative language which you have been using to program in to teach yourself programming. It's the most common form of high-level language used in education. Now let's have a look at the machine code language. This is the least abstracted of all the languages in this hierarchy diagram. It's the closest to what is actually happening on the hardware of the CPU. The programmer has to program directly in ones and zeros. And of course, these ones and zeros are being translated directly into matching electrical signals. At a simple level, a 1 would be a high voltage and a 0 would be a low voltage. So there's a direct, close relationship here between machine language and what actually happens on the hardware to run your program. Assembly language, as we covered in the last video, is still low level, but there's one extra level of abstraction. It is now something which makes it easier to program. With assembly language, we use short, typically 3-letter words, which represent a unique set of binary ones and zeros. And these short code words are known as mnemonics. When the mnemonic is received by the computer, it's looked up in a table for that processor. If a match is found, it replaces the word with a sequence of ones and zeros. This is the actual machine-specific machine code which will need to be run on the hardware. There's a direct one-to-one relationship between the mnemonic and the machine code. Assembly languages are written in assembly and they're translated by a specific assembler for that particular make and model of computer. So the command add num1 would translate using an assembler into a different machine language specific set of ones and zeros on one computer using its assembler from another computer with its assembler. One thing you have to be able to answer in the exam are some of the advantages and disadvantages of machine code and assembly. Now, other than a theoretical knowledge and understanding, it is unlikely these days that you will ever program directly in assembly language. But it's still useful to understand some of the advantages and appreciate that some people do program directly in assembly code. So, assembly language has the same level of efficiency of execution as machine code due to its one-to-one nature. You can produce incredibly precise, locally optimized and very, very efficient code. When you're programming in assembly, you have direct access to system-level features. There's no need to go through some complex software interface. All of these improve the speed of the program. In essence, with assembly language, you are in complete control of your code. Now, there are obviously disadvantages. One is that assembly code is specific to the make and model of PC architecture that it's programming on. The code is incredibly hard, if not impossible, to port over to a different style of computer. Of course, finding programmers capable of writing efficiently in assembler is hard. There's a reason why high-level languages came about. Even with a talented programmer, it can be a long and tedious process to write and debug assembly language programs. The code itself can also be very difficult to understand, and outside the original programmer who wrote it, it can be very difficult therefore to modify and maintain.